Alright, now everything when you're working with the trig functions like this, everything is based off of a couple different things. When you take a look and they say tangent of z, well, first things first, you might want to do this. You might want to go until you really remember it, kind of put SOHCAHTOA up at the top or something like that, so you know what sides you have to use. Now, when we're dealing with these, whenever you see tangent of z, z here is an angle. So that's going to clue you in on what angle you're going to be dealing with. So I'm going to be using z. Now, when I first started doing this, I had trouble remembering what was going on with everything. And I'll be honest, sometimes it gets confusing with everything to figure out exactly what you need. The first thing that you should do is you need to ID the angle. And since you're going to look for the tangent of z, this is kind of like a name. This isn't, you're not multiplying tangent times z or anything crazy like that. What you're doing is all it is saying, I want this ratio, I want the tangent ratio, which up here is TOA, which is opposite over adjacent. And it's telling me what angle is the angle that I want to look at. So I would recommend is you ID the angle first up. The angle is z. I like to put a little arc by z when I'm dealing with that. Now, the next part is ID the ratio. It says we want the tangent, so I want a tangent, and if I remember the SOHCAHTOA or however you remember it, it's going to be the opposite leg over the adjacent leg. Now, in this case, I always say look for the hypotenuse. The hypotenuse is opposite what angle? Your right angle. So the hypotenuse is always going to be the longest side. It's going to be opposite the 90-degree angle. Of which one is the hypotenuse? The 21, the 28, or the 35? The 35. So this is my hypotenuse. Now, does the tangent need the hypotenuse at all? It does not. So I can ignore the 35 in this case. Now, what I like to do is I like to draw lines until I got really, really good at this and I could just look at it and be done with it. I always draw these two different lines. There's going to be a side that's opposite, and the side that's opposite is always the side that's the farthest away from the angle. So this is going to be my opposite side, and this side right here is going to be my adjacent side. So now I know the tangent of z is going to be the opposite over the adjacent. Now what's the opposite side? What's the number for the opposite side? 21. What's the number for the adjacent side? 28. So we get 21 over 28. And if we can reduce this, we can go ahead and reduce it. Is there a number that divides into 21 and 28? Yeah, 7. 7 goes into 21 how many times? 3. And into 28, 4. So we get 3/4. And every triangle that has these angle values, and we'll be able to figure out the angle values eventually, because whatever the measure of angle Z is, it's tied to that ratio. So every angle for angle Z, the tangent is going to be 3 over 4. So if it was 46 degrees or something like that, every triangle that has a 46 degree angle, the tangent of that angle is always going to be 3/4. And that's pretty much what you do with all of these. Take a look at number 2. What angle are we looking at? C. So I need the cosine now. The cosine of C. Now, with SOHCAHTOA, this is going to give me the adjacent over the hypotenuse. So, where's the hypotenuse? What's the biggest side in the triangle? 34. That's my hypotenuse. Now the big question is, alright, from here, which side am I going to use for my adjacent side? Is the 30 the adjacent or the opposite? Alright, that's opposite. So this guy's got to be the adjacent. So if I'm using adjacent over hypotenuse, I know my hypotenuse, which is the longest side, which is 34. What's the adjacent side? 16. And then we can reduce this down. I think 2 is the only number that goes into this. So it'd be 8 over 17. I'll do one more so you can see the sign. Now for angle C here, there's angle C, and I want the sine of C, which is the opposite over the hypotenuse. Now for C, I'll draw my two little lines here. What's the longest side? What's the side opposite 90 degrees? 35. That's my hypotenuse. So I know whatever I'm going to get here, it's going to be over 35. Now with the sine, I need the opposite side. Is the opposite side going to be 28 or is it going to be 21? 28. The opposite side is the side farthest away from the angle. So there's my opposite side. There's my adjacent side. If you remember, adjacent means right next door. So if I have an angle, that's not the technical term for adjacent. But as far as angles go, it's part of the line that makes up the actual angle. So the adjacent side to this angle is going to be the side that actually makes the second part of the angle. The acute angles are always made up of the hypotenuse and the adjacent side. The opposite side is that third side that's farthest away, that you can draw the line farthest to. So the opposite side is going to be 28. Now, to reduce this down, is there a number that divides into 28 and 35? 7. Alright, 7 divides into 28 how many times? 4. And into 35? 5. So for this angle, you're always going to get 4/5.